Hello Year 9, welcome to this first lesson in sequences and series. In this lesson I'm just going to give you a brief introduction to some of the notation that we've used, and I think it may even be revision from what you've seen before. So let's get started. So first of all, what's a sequence? A sequence is any list of numbers that follows a pattern, and you can see I've written a sequence here. 2, 4, 6, 8, 10. Generally, if it's a sequence, we separate them with commas, while if it's a series or a progression, we're adding them all together. But we'll stick with a sequence for the time being. So the first term is 2. So we say this T1 equals to 2, and the little number down the bottom here, this one, tells us its position, and it's always starts with T1. There's no T0, there's no position 0 or position -1 in a sequence, and we've got T2 equals to 4, term 2 equals to 4, term 3 equals to 6, term 4 equals to 8, and term 5 equals to 10, not 8. Okay, so these are our first 5 terms in this sequence, and what I want you to do is see if you can work out a rule for this. So it's going to be T of n. If we have T of n, what's the rule going to be? So when n is 1, T of n is 2. When n is 2, T of n is 4. When n is 3, T of n is 6. When n is 4, T of n is 8. And when n is 5, T of n is 10. So I hope you guys have realized that the rule is T of n equals to 2n. And I'm just going to write down here, what do you guys think T of 120 is going to be? I hope you've realized that T of 120, the 120th term, equals to 240. And there is no T of 0, okay? We always start counting with T of 1, T of 2. And similarly, there's no T of a half. We start counting up by 1, and the number down here tells the position in the sequence, and it has to be a whole positive integer position, obviously. So now I want to show you another way of writing your sequence, and that's this. What am I actually doing each time I'm going up here? I'm kind of doing the same thing every time, and you can probably see what it is. I'm plussing 2 onto each of these. So I'm going to now do another definition, and that's this. What we do is we first of all say T1 equals to 2, and then I'm going to say, what is T of n? Well, what I do is I get the number in the position before it, and that's Tn minus 1, and I plus 2. And this definition that you can see I've written here, it's called a recursive definition, and if it's recursive it means it refers to itself. So t's like our function, and we've seen functions before, and our definition for t has another t in it. So for example, if I said something like this, okay, well, what is t of 5? Well, I know T of 5 equals to T of 4 plus 1. And we know that T of 5 equals to T of 4. And I said plus 1, but if you're racing ahead, you know what we mean. T of 5 equals to T of 4 plus 2. And we know that T of 5 equals to 8 plus 2, which equals to 10. And you might be thinking, well, how do you know what T of 4 is? Well, to work out T of 4, you've got to work out what T of 3 is. To work out t of 3, you've got to work out t of 2. To work out t of 2, you've got to work out t of 1. So you actually have to start from here and then add them all up. So most of the questions you do are going to be using this way, but this way is still handy to know, and there will be the occasional question where where this will actually help you solve it. Okay, so now that we've done this, let's try another one. And we're going to practice the recursive definition. So I want you to write the recursive definition of each of these. And we're actually going to need to start off with two base cases. So I'm going to start off with t of 1 and t of 2 equals to 1. Now, why do I need two base cases? Well, you probably recognize this as the Fibonacci sequence, and this is 2, and we get the 2 by going 1 plus 1. This is 3, and we get the 3 by adding the 1 plus 2. This is 5, we get the 5 by adding the 3 and the 2. The 8 we get by adding the 5 and the 3. So we add the two previous terms to get the next term. That's why I need to first define two terms, because I need to go back two places before I can start adding things together. And I'm hoping if you've got some paper you've already raced ahead, but if not, the recursive definition is t of n equals to t of n minus 1 plus t of n minus 2. And hopefully I'm just going to straighten up that t there, just so it looks a little bit nicer for me. There you go, that's a better t. And this is the recursive definition of the Fibonacci sequence. And a sequence like the Fibonacci sequence is much easier to write recursively. If you wanted to write a non-recursive definition, that would be a lot trickier. So we need to start with this one and this one before we can start creating our terms with the formula. Okay, let's now do another question. We're going to write the first 5 terms of this. T of n equals to n squared plus 1. Nice and easy, you can race me if you want, you'll probably write them out faster than me. So what are we going to have? 1 squared plus 1, 2 squared plus 1, 3 squared plus 1, 4 squared plus 1, and 5 squared plus 1. Nice and easy. Now the question we've got is 200 a term in this sequence? One way you could do it is write out all of these until you get up to 200 and then see if you get it or not. But there's actually a proper way to do it. So we've got the formula, and our formulas, t of n equals to n squared plus 1. Now if 200's a term in this, we know that it's going to be at a particular location. It's going to be in location 1 or 2 or 27. It obviously won't be in locations 1 and 2. So what we do, we want to work out if the location for 200 is actually in a whole number position. So we go, okay, what position is 200 in? So we know our 200 equals to the t of n. So we go, okay, we can get that then. So 200 equals to n squared plus 1. N squared equals to 200 minus 1, which is obviously 199. So n equals to plus or minus the square root of 199. But obviously we don't want the negative version, because remember our positions always have to be positive. They start from 1, 2, 3, 4. So we know that n is greater than 0. And let's actually work out what the square root of 199 is. I'm just going to put it into my calculator. The square root of 199, and we know that n equals to 14.1067 blah 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 blah. So we know that if I have t of 14, we're going to get 14 squared plus 1, and you can of course work that out, is 197. While t of 15, I hope you can read my 15 here, is 15 squared plus 1, which is 226. So we can see that 200 is somewhere between 14 and 15, but it's not actually 14 or 15, so it can't be a term in this sequence, because from 14 we go to 197, up to 15 we get 226, and no exact whole number is term gives me exactly 200, which is what I was looking for. Okay, next one, and it looks like that page is just duplicated, so let's now move on to the very last question. Find the first negative term in this sequence. Now, the very first thing we have to do is actually work out the formula for this sequence, unless you want to go the long way and actually start writing out all the terms, which you can do if you like. So what I'm going to do is I'm going to look at what's happening here. I'm going down by threes. So let's see if you can work out a formula for t of n. If you want to spend some time thinking about it, just pause the video and try to work it out. But I'm going to give you the formula now. We know that t of 1 is 200, t of 2 is 197, and so on. So I think I need to start off with 203 and then take away 3n. And I want you to double check if that's actually going to be correct. Let's think about it. If n's 1, we've got 200, because t of 1 is 200. If n is 2, I've got 203 minus 6, which is 197, and so on. And you'll see this is called an arithmetic series later on, and there's ways you can work out this formula without just having to do it in your head. Okay, so now let's actually solve our question, which will be fun. So we want to work out when is 203 minus 3n going to be less than 0, okay? And nice and easy to solve. That's going to be 3n, and I'll do this in two steps. I won't race too far ahead. So we've got here 203 must be less than 3n, or I can write this as 3n is greater than 203. So n must be greater than 203, and divide that by 3 and tell me what you get. It should be 67.66 ... So that means when n's exactly 67, when n's exactly 67.666, this whole thing goes to 0, but n can't be 67.6666 because n has to be a whole number. So we know that 67, it's not quite there yet, but 68 should be the first negative term. And let's actually work it out. Let's work out what t of 68 is, and I'm going to have 200 minus 3 by 68, and I'm really hoping this is the first negative term. So we go 200, and I'm just typing into my calculator, minus 3 by 68 equals 2 minus 4, and t of 67, and let's take a look. 203 divided by 3, and t of 67, so I was looking at my calculator as I was drawing that, t of 67 equals to, oh, and hang on, I can see the error here. Can you see it as well? Pause your video and see if you can spot it. We don't need to redo anything. I wrote here 200, but what should I have written? You can say it, I can't hear you of course, but if we go back we can see actually what we needed to write here was 203. So we've got 203 minus 3 by 68. 203 minus 3 by 68 equals 2 minus 1, and that's got to be the first negative term, right? That absolutely has to be the first negative term. Otherwise we can go t67, and let's just test out t67 just for fun. So 203, not 200 because we had a 203 there, minus 3 by 67 7 equals 2, and we don't want this one to be less than 1. Yeah, I know you can already see that it's going to be 2, but let's do it anyway. Equals 2. 2, obviously, because we're going down by 3's. So, therefore, minus 1 is the first negative term, is the first negative term. And of course, minus 1 is T68, or the 68th term. So there you go, guys. That's a brief introduction to sequences and series.